All right, welcome to HS Navigator's Young Scholar Program for 2022. I know a lot of you are here right now, and that's great. Just since it's the first webinar, I'm just going to give some other people a few more minutes to get in because I know I've got a lot of emails about some tech issues that people were having and other things. So I want to give everyone a few more minutes to get some stuff sorted out, and then we'll get started with our first presentation today and a little bit of an introduction into what this program is actually going to be. It's great to have you guys here, though. All right. So it's 12:03 right now. I think as some more people join in, they can keep joining in and they can catch up along as we go. So welcome everyone once again to the Young Scholar Program for 2022. I'm Mayor. I'm going to be talking a little bit more myself as the presentation goes on, but basically I'm the founder of HS Navigator, which is the program behind this Young Scholar Program. And I'll talk more about HS Navigator tomorrow in a little bit of a session that we're having. But just for now, it's really great to have you guys here to see the turnout. Like right now, we have 77 people in here, which is pretty amazing. And yeah, I'll get started with my first presentation. So basically, the Young Scholar program is going to work kind of like this. It's going to be like a presenter, like me or someone else from the team, or maybe some people from industry joining in. They're going to give some presentations on topics that they're interested in, topics that you guys are interested in, and we're just going to go from there. And today, my topic is going to be on introduction to R, and I'll talk more about what R is and everything you need to know for R as I go along. So just to get started, I'm pretty sure I checked my screen is sharing, so hopefully that works out. But yeah, let's get started. So this is sort of a disclaimer that's on every single slide that we make, which is just to say that we're not like an authoritative source of information. We're not like a actual school or anything like that. We don't really. It's just sort of a liability thing. It's just saying that we're not the source of truth and all this information. If you guys want to learn more about them, then feel free to go out on the internet, learn everything you want about the topics on your own. Because while we tried our hardest to do all the research for our presentations, there still could be things we messed up on. We don't want to, and that's sort of just a fault of us. We're not like professors or anything. We're just people who are really interested in these topics and want to teach you guys about them. So just some stuff about me. This is just some information about me. Currently, I am an intern at Amazon this summer, and there's more stuff about that, about like the actual project that I'm working on, and some of the work that I'm doing tomorrow. And I'm also a sophomore at Georgia Tech, and I study computer science. I'm the founder of Aegis Navigator, like I mentioned before, and that's sort of the program behind this Young Scholar program. And I also have some certifications, which this isn't that relevant to this presentation, but I'll talk more about them tomorrow. So let's talk more about our topic for today. So our topic for today is on R. And R is basically like a programming language. You can think of it, if you've done stuff with like MATLAB or some other thing like that, it's kind of a programming language, but it's also used a lot as just a fancy way of working with data and working with like analyzing data. And so it is an interpreted computer language, like it is a programming language in a sense. And you don't really need to compile it. All you need to download is just R, and you can run any R program that you want. And how this presentation is going to work, by the way, is I'm going to go over like some like topics about the on the slides, and then I'll switch over to a demo of the actual topics, just so you guys can see like hands-on what is the stuff that I'm talking about, and how does that stuff sort of work in the grand scheme of things. So R is a programming language I mentioned before, and it's used a lot in sort of analyzing data. People always hear like data analysis, and this is one of the main tools that people who work in that data analysis field sort of use. It's basically taking a bunch of information about like people or a bunch of information that you gather from surveys or stuff like that, and sort of breaking it down into a way that we can understand the patterns and the trends in it. And it's also used in stuff like machine learning as well, if that's something you're interested in. And it's open source, it's completely free to use, just like most programming languages are. And you can actually use it with a bunch of different stuff too. Like if you have some experience with different programming languages besides R, you can actually use both R and that and combine them together and do some really powerful stuff. And there's also a lot of like public support for R. Like it's not just one sort of small programming language you can't really do much with. There's like thousands and thousands of people who have made free packages for R that can sort of expand the usage of that of R beyond what like it's normally meant to do. And there's stuff like those repositories are everywhere. There's places like GitHub or CRAN or other repositories. Like if you're familiar with Python, any of you, then it's the same thing as libraries in Python. There's so many of them available for R as well. And they can run on any OS. If you're running on a Chromebook or you're running on a Mac or running on a Windows, and you can use R wherever you want to go. So why do people want to use R? So one of the reasons you want to use R is you can make powerful graphics and fast calculations. So people who have a lot of data and they want to quickly be able to make graphs on that data, instead of having to go into Excel or even do the graphs by hand, R can just in a few lines make really, really powerful graphs and really high quality graphs as well. And it can do a lot of like really complex calculations that would be difficult for you to do even with a calculator. R can do them really quickly and really efficiently. It can run on any OS, which is a pretty big thing. Having the ability to write a program and have it run everywhere is it's so convenient. And it's something that a lot of other programming languages can't really attest to. There's a lot of opportunities, like for people who are interested in like looking for jobs and stuff like data analysis or anything like that, then there's millions of jobs available. And a lot of those jobs like look at people who have experience with R as like really beneficial. That's something that they really want a candidate for those. And it's also used in machine learning. Like it's not just a language for making pretty graphs and making like sort of that statistical analysis. It's also really used in machine learning and really using like actual like industry machine learning standards as well. So what are we going to be covering today in this presentation? Basically, we're going to be covering how to install R in RStudio, like how to actually get R running on a computer, some basics about R, some data structures, which will go more with what those are, some functions that you can actually do straight off the bat with R, flow control, which is a little complicated to explain, but I'll talk more about that when we actually get there. User-defined functions, like what can you personally define that R functionality to have. Data manipulation, like how do you actually do the data analysis work that people can do with R? And also data visualizations. How do you make those really cool graphs? How do you make the really pretty graphs? How do you do all that really quickly and efficiently? So first, we're going to go over how to install R in RStudio. So in order to install R, first you need to actually download R. And if you just search like download R on Google, it'll probably link you to the same page. And this link, cran.rproject.org, is how you install R. And basically just install it for whatever OS you have. And then you want to install it for the first time. There's be a link that says install R for the first time. And then once you download that, you just download the file and install it like you would any other application. And once you run it, you'll get something like that. But you don't just want to download R. Like working with R, you can just do it right off the bat. But something that's really helpful is what's called an IDE. For people who have experience with programming, you might know what IDE is, but it's basically like an interactive development like interface. It's like where you can actually write your code, and it's a lot easier to use than using the base R, and it gives you a lot of features as well that we'll go a little bit into. And there's like some licenses you can buy, but you don't need to pay anything for R. You can just download the free version of it for the desktop, and it'll do everything that you need to do perfectly fine, and it'll work right off the bat. So once you have R and RStudio downloaded, that's what sort of RStudio will look like when you open the app. By the way, I'll show you guys it as I go along too. So once you have RStudio downloaded, there's going to be 4 panels on the screen, and I'll actually show you these 4 panels. So you have your code editor, your console, your workspace, and your plots. So if I switch over here, this is actually, like I have RStudio downloaded for myself. And as you can see here on the top left, this is sort of the code editor. This is where you see the code that you write. Here is the console, which is just where some of the output from your code goes. Here is the environment, where I'll just show you a sample. Where any variable that you define will go here in your environment, your variables. And then plots is if you draw any graphs, they'll all show up in this blank space here. And that's basically the general gist of what R has to offer, like what RStudio offers. And it also has some customization options. So if you go to Tools, Global Options, you can have to change the appearance. So for all you guys that like, I don't know, who like dark mode, I'm a dark mode. Feel like I only like dark mode in most of my applications. You can do that. Basically, you just have to go to Tools, Global Options, Appearance. You can change a bunch of things. You can change like your font. You can change your font size. I can make my font size a little bigger for you guys if you need. Apply. And I can also change just some of the stuff about how my code like editor works. So let's say I change it to Cobalt. Actually, that's quite dark. Actually, I'll change it to this Crimson Editor. And as you can see, it changed some of the colors to the code editor. The reason I'm using light mode for right now is because it's easier to show up on the screen. But for me personally, I usually code in dark mode and everything. But that's a personal preference thing. And anyway, so that's sort of some of the customization options that RStudio provides. So yeah, Tools, Global Options, Appearance. And by the way, if you ever feel like I'm going too fast or anything, I'm going to be sharing all these slides and all of this, like the code that I write as well after this presentation is over. So you can always feel free to like either look back at this recording because this whole lecture is being recorded, or look back at the slides and the code. You can follow along with that and follow along in your free time or explore as much as you want to with this. So there's no rush to like you have to follow everything right now. Everything's being recorded. All the slides and all the scripts will be provided to you as well. So yeah, you can change the font size, some stuff like that. So now we're going to go over some of the basics of R, like how do you do anything in R? What is R? How do you code in it? So one of the basics of any programming language you'll come across is one of the basics in any programming language you come across is variables. So variables are just temporary storage space. Every programming language uses a variable, and it's like variables in math as well. Like if you have x equals 2, x is a variable. Same thing in programming languages. In fact, it's the exact same thing. You have whatever variable you want to store equals whatever value you want to put into it. And it's sort of naming conventions. So every programming language has different conventions on how you can name variables. And like only dot or underscores are allowed in this. And I saw one question that said, do we have to download this and follow along? You don't actually have to download or follow anything. That's all up to you. And there's going to be this recording as well. So feel free to follow along if you want, or like follow along in your free time afterwards if you want. And in terms of other questions, I'll get to those at the end, because I also need to get through some of this like slide presentation. And then when I have time at the end, I'll go through some of you guys' questions as well. And there's also going to be an email at the end that you can actually send all your questions to. I think it's like YSP2022@hsnavigator.org. But at the end, there's going to be an email that you can actually send all your questions to for every webinar. And we'll make sure to answer your questions there. So if you have any like personal questions you want to ask that you don't feel like asking in the public chat, you can always send those there. All right, so continuing on. So let's say some examples of variables. So let's say you have variable 1 is equal to 10. Variable 2 is equal to phone, and pen is variable 3. So these are like different ways of instantiating variables in R. Instantiating just means like setting the value of. And you can actually check the variable values using the print command. And print is in like every programming language. You just print it out to the console. And you can combine multiple variables using the cat command. So let's take a look at how some of this stuff works. So let's say you have variable 1 and you want to set it equal to phone. So you run this line of code. And by the way, if you want to know how to run code, you just either highlight it, or if you write it out, you can just click run and it runs it line by line. So now here in our environment, variable 1 is equal to phone. Same thing here. The arrow is pointing the direction. So variable 1, the pen is now variable 1. So variable 1, if we run this, now it's pen instead of phone. Or let's say we want to set feather to variable 1. Now variable 1 is feather. And then you can either just check the value here on the bottom, you see it prints out feather, or print it, and there, it prints out feather. So it's just a lot of different things that you can do with just basic variables and printing them out. So another thing, the basics of R is what data types. So data can be of different types. So like this is a common thing to all programming languages. Like you have integers, which are like numbers. You have like strings, which are like actual text. You have characters. You have a bunch of different data types you can have, and especially in R. So data types can be numeric, like numbers, decimals, stuff like that. So those are numeric data types. In R and Python, by the way, like you don't actually set the types yourself. Like, and I know in some programming languages like Java, you'd actually say integer num1 is equal to 2. But in R, or if you're working with Python, then you actually don't have to set the types. It sets all that types for you. And you can use this command, this class command, to tell, or class or type of, to check the data type of the variables that you're working with. You also have characters. Characters are basically text. Anything that has to deal with text is a character data type. And then you have logical or Boolean, which is basically just true or false. So as you can see here, when we try saying character 1 is equal to hello, it says hello cannot be found. It gave an error. And the reason that it gave an error is because characters always have to be surrounded by double quotes. So you always have to, any like text you're trying to write, you have to surround it in double quotes. Otherwise, the compiler doesn't really know how to do with it. And then over here, when you're actually doing logical or Boolean, your true or false have to be in all caps. That's sort of just an R specific thing. Like you should remember that if you're dealing with true or false, you just put them into all caps. So if you can see here, num1 is 3. Here, now we have on the right side, num1 is 3. And 3 is obviously a number. It's not a text. It's not surrounded in double quotes. So the type of 3 in the bottom, as you can see, let me see if I can make this a little bit bigger. As you can see in the bottom, the class of num1 is numeric. And the type of num1 is a double. It's just a type of number that it has. Same thing with character. If we try running character1 equals hello, you'll notice that there's no double quotes on the side of it. So it throws an error because it doesn't know what hello is. It just thinks it's another variable or something. So now if you put double quotes, now on the right side, character1 is hello. Same thing with variable1. And the class of that is obviously a character. And then same thing with the logical operations. True has to obviously be in all caps. And same thing with class. It has to be in all caps. That's just, it's kind of a tricky thing, but it's something that you just have to get used to as you work with it. And then the final data type is, complex numbers. So if you guys have gotten to complex numbers in math, yeah, it's basically just imaginary numbers. And that can actually be put into R as well. So complex numbers always in the form A plus BI. This is sort of a math thing. If you've done complex numbers, you'll understand it, but it's not really something that's that important. It's not used all that much. So complex numbers, and as you see, it shows up as complex and 1 plus 2i. Okay. So now we have some operators. Operators are basically how you do, like, what can you do with variables? So you can do logical operators where if you have like true or false operations, you can see, all right, true and false, true or false, or not, and or not. That's basically what these three symbols represent. And is if both things are true, then it returns true. Or if one of them is false, it returns false. Or is this or that. So one of them has to be true, and then the entire thing is true. And then the exclamation point is just the opposite. So the opposite of log 1 is true. So exclamation point log 1 would be false. And the next sort of operators you can do is, hold on a second, is assignment operators. This basically just lets you set the value of variables like we did before. If you saw at the beginning, we were setting the value of variables to that. And then we have relational operators. And these are sort of the operators that can do like less than, greater than or equal to, or not equal to. So that's like going from left to right, greater than or equal to, and not equal to. As you see, the not from here just goes in front of the equal sign. So that's, once you remember the not, it's pretty easy to remember the rest. So assignment operators, variable 1 equals phone. Or here, the pen is pointing, the arrow is pointing to var2. So var2's value here gets set to pen. And then here, feather is pointing to var3. So var3 gets set to feather. And then logical operators, if you have true and false, let's just true and false, then true and true will give you true. True and false will give you false because something, they both have to be true in order for it to return true. And then the same thing for or. If you do true or false, one of them is true, so the whole thing returns true. And then relational operators, these are sort of like basic math concepts, but how to represent them in R. So, you know, if you have x is 5 and y is 6, as you can see on the right, x is 5, y is 6, then you can say, is 5 less than 6? True. Is 5 less than or equal to 5? True, because 5 is equal to 5. Or is x not equal to 5? That's false, because x is 5. So it's just basically generic ways of going about just like greater than, less than, and stuff like that. And then the final type of operators is arithmetic operators. So you have your addition, your subtraction, your multiplication, division, and then you have remainder and quotient, which are just what's left from when you divide and then what you divide by. So those are pretty simple too. It's just normal math operations, just how you would represent them in R. So you can add, subtract, multiply, and divide. And then if you put 2 percentage signs, it gets you a remainder. percentage sign slash percentage sign gets you quotient, and this caret gets you the power of. So it's just basic ways of doing math within R. So now we're going to go over data structures in R. So data structures in R, there's actually a bunch of them, and we're going to be going over most of these, but if you, as always, if you feel like we're going too fast, you can always feel free to look at this recording later. So the first data structure is called a vector. And a vector is, it might sound kind of complicated now when I say homogeneous single-dimensional data structure, but I'll explain what that means. Basically, a homogeneous data structure, if you've heard this in chemistry before maybe, homogeneous basically means that all your elements are of the same type. So you can only make a vector that has all numbers or a vector that has all characters. You can't have both numbers and characters in the same vector. That just throws an error. And it's not like, why can't you do that? It's just, that's sort of how vectors are made. And if you want to create a vector, then you do it with a symbol C. So if you want to make a vector of 1, 2, and 3, you do C, and then parentheses 1, 2, 3, and that makes a vector of 1, 2, 3. And 1, 2, 3 are all numbers, so that works out. And then these are some demos that I'll explain, and then I'll actually do the demos myself on the slide. So the first demo, we're obviously we're doing a combination of 1, 2, and 3, and then we're combining them together, and that's a numeric vector. And then A, B, and C are all characters, are all like text. So then that becomes a character vector. And then true, false, and true, which you can actually represent with T and F. Instead of just writing out true and false, you can just write T and F. And that's a logical vector. And then one of the last things that I want to show you is priority. So if you have, actually, let me just show this off in R itself. So in this first vector, we're taking 1, 2, and 3, and then using the keyword C to combine them all into one vector, which is vector 1, 1, 2, and 3. Vector 2, same thing. It's A, B, and C, they're all text. And vector 3 is true, false, and true. If you see on the side, it actually tells you vector 1 is a numerical vector. It says null. Vector 2, CHR, is character. Vector 3, logic, is logical. So it actually tells you what type the vector is as well. But let's say you have a vector with multiple different types. So what does it do there? So what it does in that case is if you declare this mixed vector here, it tells you that it's a character vector, but you might be saying, but there's numbers in here. How is it a character vector? How can you actually instantiate this? And that's where a key thing that comes up is this sort of idea of priority. So if you have different elements, like text and numbers in a same vector, then it actually converts some of those data types in the other ones, and there's a priority. So characters have the highest priority. So if we have a character in this vector, then it converts the 1 and 2 also to characters because they have a higher priority. So you can see the 1 and 2 now have double quotes around them, showing that they're not numbers anymore, they're characters. And then if you do this, mixed vector 2, then actually, since numbers have a higher priority than these logical operators, it converts the true and the false to 1s and 0s. And it still makes a vector out of them, but a number vector. And then if you have all three of them in one, it converts everything into a character because the characters have the highest priority out of the three of them. So that's just like an interesting thing that you can do with vectors in R. Next data structure that we have is lists. So lists are heterogeneous, which is basically the opposite of homogeneous. And what that means is you can have multiple different types within your data structure. So you're not limited to having all characters or all numbers or all logical operators. You can actually mix and match them, which is, for a lot of cases, that's what you want. You're not going to have data of all numbers. You're going to have data of different things, like numbers, text, logical, stuff like that. And it's also So I didn't mention this to the other one, but single dimensional basically just means that, actually it'll make more sense when you see multi-dimensional, but it basically just means that you can't have like multiple rows in one. You know, if you think of it like a table has like one row and then a second row and then the third row. In this one, everything's on one row. It's not, there's no different rows you can access. And heterogeneous, like I said before, means elements of different data types can be stored. And the keyword for instantiating a list is just list. It's a lot more convenient than vector. So list, if you want to instantiate a list, so list one, you just do list of whatever you want to throw into it. So you want to throw a number 1, sure. A character A, sure. A logical true, also you can do that. And it instantiates them all together and it shows up in this format. And an interesting thing that you can do with lists is you can actually put vectors inside of lists. So if you want to have a list of vectors, you could do that. So you can make a vector of 1 and 2, then make a vector of A and B, and then put them all together into one list and actually have that work. So, this is actually something that I meant to show. So when you're taking out elements from a vector, going back to a vector actually, there is actually, if you want to take elements out, like let's say you create a vector, but you want to access, hey, what's the second element in this vector? Like what's the second thing that I put into this vector? Then what you can show is here, you can't just do whatever vector parentheses 1. That doesn't work, because the way that you access elements from a vector is using these square brackets. So if you make this mixed vector and you try running with just normal parentheses, it says, hey, you can't find this. How do I do this? It's an error. But if you put these square brackets around it, then it says, oh, okay. If you want to access 1, the first element, then hey, I'll give you 1. If you want to access the second element, it'll give you A. So the second element here is A. And if you want to access like a group of elements, like say you want to go from 1 to 3, then you can do 1:3, and it'll get you everything within this range. So it'll give you the first, second, and third element. Is this the beginning? This is the end. And now going on to lists. So how do we instantiate a list? The keyword list. And over here, now it shows up as data. So this section is where a lot of your data structures will go. Values are just like normal values are showed up here, and data, which is actually groups of these values, shows up at the top. So list A is a list of 3 things, and it has a number 1, the character A, and the logical true. It's pretty convenient how it shows it all up here. And then if you print out this list, it shows up like that. And a lot of things with data structures in R, it actually tells you how to access the values from them. So if you want to access the first value, it tells you here, all right, this is the syntax to have it. This double quote, this double like square bracket 1 is how you access the first element. So if you do list of the double square brackets, it tells you, hey, this is a numeric one. This first element in the list is numeric. The second one, that's a character and logical and so on. And now what I mentioned before is, let's say you want to have a list of vectors. Then you can actually create 2 vectors, 1, 2, and 1, 2, and AB. And it actually does the list for you. It does everything for you and makes a list with the first element here being a vector of 1, 2, and the second element being a vector of A and B. And you can actually access different things from that. So let's say you have all 3 of them. You have a number vector, a character vector, and a logical vector, as you can see here. And you want to access something from that list. So if you print out list 2, it shows up like this. And if you want to access that, then you say, let's say you have here, this 1, and then you can access any element you want from here using the same square bracket method that you do for a vector. So you want to access the first vector and the second element, Sure. You want to access the second vector in the second element, you can do that as well. And basically, there's a lot of different ways you can access elements from those data structures. So now we have matrix. Matrix is basically, it's really similar to a vector where it's homogeneous, but now you have 2 dimensions to them. So a matrix is basically just, you take 2 vectors and you make them into a grid. So 2-dimensional basically just means you can make it into a grid of however many dimensions that you want. And the keyword here is matrix. So really similar to vectors, you instantiate, let's say you have, so here, you instantiate a matrix. Here you instantiate a matrix of a vector 1, 2, 3, 4. So first it makes a vector 1, 2, 3, 4. And then you do matrix of that, and it makes this really weird, like 4 rows by 1 column matrix. But 4 rows by 1 column is kind of like awkward to look at. So let's say you want to make it 2 by 2. You can actually do number of rows is 2, number of columns is 2, and it breaks it up into 1, 2, 3, 4, broken up into 2 by 2. As you can see right here. And it actually shows that up here on this environment section as well. Your matrix shows up here, and it's a really cool format as well. So you can see 1, 2, 3, 4 up here or down here if you want to look at it like that. And let's say you want to make it a 2 by 3, but you only have 4 elements. Obviously, that throws an error because you need to have the same number of elements you're trying to define rows and columns by. And then another like kind of neat thing that you can do is, let's say when you're making this like 1, 2, 3, 4, it says 1, 3, 2, 4 because it's going like top down and top down. But let's say you want to go left, right, then you can just do by row equals to true, and it does it left, right for you. Right here, 1, 2, then 3, 4. And then the last thing is, how do you access elements from this? Like with every data structure we've gone so far, we've been showing how do you make it, and then how do you access elements from it. So how do you make it is using the matrix command. How do you access elements from it? Well, it tells you that as well. Here, as you can see, the first row is square bracket 1, comma. And then whatever else you want to access is either 1, comma 1 for this, or 1, comma 2 for 3. Same thing, 2, comma 1 for this, 2, comma 2 for that. So if you have this matrix here, matrix 4, and you want to access, let's say 1, comma 1. 1, comma 1 here gets you 1. So if you run this, you get 1, and the same thing for 2, comma 3. The next data structure is an array. So an array is homogeneous, so you can't have different data types in it, but it's multidimensional. It's kind of like, it's similar to a matrix, but it's like stacking different matrices on top of each other. It's a little complicated to think about like conceptually, but it's basically like a matrix, but with more dimensions than just 2. So let's say here, it's easiest to show you guys how to make this. So let's say you have this vector 1, 2, 3, 4, 5, 6, right? And you want to run that. Let me see if I make my choose. Like some people are mentioning that's blurry. Let me see if I increase my font size to maybe 14 and apply that, if that helps fix any issues. So anyways, so let's say you have this vector here, 1, 2, 3, 4, 5, 6. And you have vector 2 here, 7, 8, 9, 10, 11, 12. And what you can do is make an array with the combination of those 2 vectors. And I'll explain what each part of this does. So array 1, here the dimensions you do is another vector, and 2, 3, 2 basically defines how many different dimensions you have. So you have a 2 by 3, you have 2 by 3 tables, and then you have 2 dimensions of that. So this is a 2 by 3 by 2 array. So 2 by 3 relates to this. So this is 2 rows by 3 columns. And then the 2 dimensions relates to, you have this top dimension and the second one. It's a little confusing to think about, I know, but for a lot of use cases, this can be helpful. And in order to access the elements in the same way, it's just the same thing. So you have 1, 1, 1 gets you this one. So here, 1, 1, 2 would get you here 1, 1, and then the second row. So 1, 1, 2 should get you here 7. 1, 3, 1 would go 1, 3, 1, so 5. And there returns 5. And then the last data structure is a data frame. And this is what's used in a lot of machine learning applications. And this is like the most powerful one out of all of them. This is where people store like hundreds and thousands of data entries, and it's the most convenient one to use. You can basically think of it like an Excel sheet in R. You have rows and columns and everything like that. So this one's like really powerful. It's really hard to go over everything that has to do with data frames in just a short time. But basically, you can instantiate a data frame saying that fruit name is like the first column. And all of your columns are defined like this. You have fruit name being the first column is a vector of apple, mango, and grape. Fruit cost is another vector of 10, 20, and 30. And then once you actually instantiate that data frame, it makes this rows and columns for you with apple, mango, grape, and each of the costs you declared it for it. And then you can use this $sign to access any rows that you want. So let's say you just want the names. Fruit, dollar, fruit name. Fruit is the name of the data frame, by the way. If you want, how much does it cost? Fruit, dollar, cost. You want to access the first fruit name, you can access it just like that, just like you access any other vector. So the next thing is sort of inbuilt functions with R. So R is a bunch of inbuilt functions, and I'll go over like the general idea of them, but a lot of these, it's hard to really figure out what they do if you don't play around with them for yourselves. So you have str, which gives you a quick preview about the structure and contents of an object. Head, which gives you the first few rows of a data frame. So let's say you have a data frame and you want to just see like the first, like, it has 1,000 entries, and you just want the first 6 or the first 5. That's what head does. And tail is it's the opposite of head. So if you have 1,000 entries, it'll show you the last 5. And some of the other functions that are inbuilt to it are tables, which provides like frequencies of the column values, and minimum. So let's say you have this table here, and you have like the ozone temperatures, you have solar temperatures, you have wind, month, days. Then a table for that, table of the air quality per month gets you the frequency of how many times this value shows up. Table, the minimum value says, all right, so if we do table of air quality per month, we have 5 shows up 31 times, 6 shows up 30 times, so on and so forth. What's the smallest value of air quality that we have? Obviously, it's 5, so the minimum returns 5. Max is just the opposite of the same. It's the same thing. It said you want the maximum value. So here it goes 5, 6, 7, 8, 9. 9 is the biggest value, so max of the air quality return 9. Flow control in R. So flow control is basically about how do you break up your code? Like how do you actually code in R? So this is sort of similar to all programming languages. So for those of you who have experience with programming languages, this will be pretty easy. For those of you who are new to it, it's probably going to be your first introduction to it, but it's pretty self-explanatory what you think about it. In terms of like how the code is written, it's self-explanatory. Sort of like breaking it down into like decision making, something that just comes with time. It comes with working on it and comes with work playing around with it. So let's say here in the sample situation, you're looking at the same air quality ozone table, and you want to see, all right, if my air quality is above 150, then it's unhealthy. Like if I want to know that is the air quality of this area unhealthy, and if it is, print it out. Say that okay, the ozone level is unhealthy. So here we have if the whatever condition we want. So let's say here we want the ozone value is greater than 150, then we print out the ozone level is unhealthy. And you can also do if else, where let's say if our ozone level is greater than 150, then we print that the ozone level is unhealthy. Otherwise, if that's not true, then say that it is healthy, because it's either healthy or unhealthy. There's no in between. And this sort of graphic in between is a pretty good way of explaining it to it. So let's say it's snowing outside. If it's snowing, then you're going to wear boots. You're not going to wear sneakers. But if it's not snowing, then you're going to wear sneakers. It's the same sort of idea. It's just breaking down whatever code you have into logical pieces and making decisions based off of that. That's what flow control essentially means. And then the same thing with a lot of other programming languages is loop statements. So loops basically just say, let's say we look at a for loop. In a for loop, we first test this condition. We say for whatever number I in this range of 1 to 8, we print out that number. So it first checks, all right, let's start this number 1 in number 1. Let's say we have I in number 1. It's being saying everything in the range from 1 to 8, that's what num1 is. Everything in the range from 1 to 8. For every number in there, print it out. So it says, all right, 1, print it out. Then next number, 2, print it out. 3, 4, 5, 6, 7, 8. And then eventually, once it gets to 8, it says, all right, then the next number that I have, 9. 9 is not in the range from 1 to 8, so I'll stop printing there. Same thing over here. If we have a while loop, in this one, instead of testing this like first condition every single time and then executing and going back and forth, here we say while this condition is true. So we do everything until this condition is false, then we end it. So while loops say, let's say we have number 1 is equal to 1. Then while that number, like you basically say it how it's coded. So while that number 1 is less than 10, we print out that number and then add 1 to it. So 1 is less than 10, print out 1. And then we add 1 to 1. So what number 1 is now 2. 2 is less than 10, so print 2, and now it's 3. 3 is less than 10, print 3, add 1. So on and so forth until we get to 9. 9 is less than 10, so we print it out, but now our value is 10. And 10 is not less than 10, so we stop printing out. So just to show that off into R, let's say we have like our for loop here. Number 1 is here. The number is from 1 to 8, and we want to print out everything here. Print out 1, 2, 3, 4, 5, 6, 7, 8. And the same thing here with that while loop. Now we have user-defined functions in R. So let's say you don't want to just do whatever R says you can do. You want to make your own functions. Let's say you want to take some input from the user. Let's say I want to enter my name, enter my state, and say, welcome my name from my state. How do I do that? Here, readline is something that lets you take in user input. So name, it reads the next line that it puts in. So it says, enter name. You type in whatever name you want, type in whatever state you want, and it prints it out by combining them together. And then if you want to define your own functions, it's a similar thing. So a function is basically just a set of code that you want to write that takes in some values and puts out another value. So here, intro, we're defining intro as the name of a function that takes in a name and a state. And then it just prints out welcome name from state. It's the same way of doing the code, just 2 different ways of approaching it. So let's say we'll run this. It actually prompts me here, and I type in my name. And then now it'll take in our state. Oh, my bad. Type here. I'm from New Jersey. And if you run this, welcome my name from New Jersey. Same thing with here. If we put in this function of welcome name from state, and then we send in the name as Mehar and the state in New Jersey, then it prints welcome Mehar from New Jersey. And you can do a bunch of different functions with that. You're not just limited to like adding user input. You can do division, you can do whatever your mind wants to do, you can do in a function. Now we have data manipulation. So one of the big things that you want to do with R is, obviously you don't want to just like work with numbers and stuff like that. You want to work with real world data. So how do you bring in that data? A lot of data is what is known in a format called CSV. And CSV is a pretty standard way of uploading data to the internet or collecting data. And it's just basically what CSV stands for is comma separated values. You basically think of it like a spreadsheet, but instead of having like those like cells that you see in like Google Sheets or like Excel or something, it's just separated by commas. So you can either read in values by using the base package, which says read.csv. You can use this different package, and a package is basically some code that someone else wrote you can take advantage of. And you can use that to read a CSV, or you can use this data.read package to read a CSV. And I'll show off what that means. So basically, you have some CSV file stored somewhere on your computer. Here's where it's stored for me. And you basically just read that file, and you can actually read in a bunch of data from that file. So now you have this data within this file, and you can print it out and you can do whatever you want with it. And then there's different ways you can do it. You can use this reader package, which you install packages using install.packages. That's what this means. And then you define whatever package you want to use by saying library of whatever you want to use. You could read it using that, or you can read it using this table data.table library as well. So let's say I use this library, and then I'll read it from here. And so you might be wondering, like, why is there 3 different ways of reading like a CSV file? Like, I just want to read it once. Then the reason is because using some of these other different packages, like data.read, can actually be 100 times faster than the base packages because of some like optimizations they made in the code. And you can install packages by using this sort of like GUI interface. You go packages, US, and then whatever package you want, or you can install them through code using the install.library package that I mentioned before. And this is basically just some neat packages that R has that you can download and some stuff that to do. So dplyr basically lets you do some cool data manipulation. You'll see the symbol a lot. This basically just means like a pipe symbol. It'll take whatever data you want and then send that to the next thing. So let's say you want to take, let me just show you this actually. Let's say I use this library here, and I want to read this CSV, and I want to filter out everything whose state is in New Jersey. And this will actually send in everything in my data. Let's say view it. Everything in that spreadsheet that was here that is from New Jersey will get shown up here. So it's a pretty cool way of just taking in data that you want and filtering out specific things you need. So you want a state who's New Jersey, who's from my high school, South Brunswick High School, or whose name starts with AIM, or their first name, stuff like that. You can do some pretty cool things with that. And next thing is data visualization, which is a pretty big thing in R. It's a pretty amazing platform. Like, I can't really show everything this platform does. I can just show you some pretty cool tips and tricks that it has. But essentially, you can do all the graphs you want, all the graphs you learn in school, like bar charts, box plots, histograms, scatter plots, line graphs, literally any graphs you could think of, someone probably made a package for in R. And one of the best packages for it is this package called ggplot, which just gives you a bunch of tools that you need in order to create these plots within R. It's a package and allows users to basically make whatever graphs that they want from the ones before and make them in like 1 or 2 lines. Like this one line here can make an entire graph for you. And you just have to send in the data, which is in a data frame format, whatever aesthetics that you want. Like let's say you want your X and Y variables to be switched, you want like cool colors, you want different size graphs, or if you want like to choose what type of graph you're creating, all you have to do is send in that value using ggplot, whatever data you have, whatever aesthetics you want, and then whatever type of graph you need, and it does everything for you. And just to show off like some cool examples with that, let's say you have this data, the data from before, and you want to make a histogram of that data. You literally run this one line. 1 second, let me actually put the library in. And then you literally just put this one line here, and you immediately have a histogram. And then you want to make it blue, you can turn it to blue. And you can change the width and everything. And there's so many different values. You can just play around with it, and there's documentation online for how to go about making all these changes you need to do. And this package called Tidyverse, basically, if you install this one package, it'll have everything you need. It'll have your plotting, your data manipulation, your reading your CSVs, your data frames, everything you need. Everything that you would need for a package is all within this Tidyverse package. So all you have to do is go over here and do install the packages for Tidyverse, and it'll put everything that you need for working with R into this one package. And this is just sort of basically looking at some of the demos that I had, like change the color like I showed you, changing the width, and then some other graph demos. You can take a look at the slides later to look at these if you want to like play around with it yourselves. And this is like making a graph of all the interests for the people who applied. This is sort of which interests were the biggest, and you can actually look at these afterwards to see how I went about making these graphs, how I went about splitting the rows and stuff like that. And it's just a lot of really powerful things you can do. And as you can see, these are all within like just 5 or 6 lines of like writing. You can make insane graphs that would take you probably like a really long time to do with Excel or Google Sheets or something like that. These are just basically just some graphs that I made. Here's like in like 3 lines, it took all the hundreds of thousands, like all the hundreds of data, the entries that I had, and made a graph of which states are the most popular for you guys. So most of you guys are from California and stuff like that. And that's basically the end of the presentation here. And as I mentioned before, like I know we went pretty fast for this, but there's always like this recording for this, and we'll send out the slides and the actual code that I wrote. So if you want to play around with that, add in any data that you want, there's always you can do that, play around. And that's probably the best way to learn this too, is just experimenting with the different graph options and doing whatever you want. And if you have any questions about like setting up or some of the specific graph stuff that we wrote, and you didn't get a chance to sort of ask us here, always send your questions. You can send all your questions for any webinar to ysp2022@hsnavigator.org. And that will make sure to answer whatever questions you have. Whoever's presenting will answer questions specific to them, and all your questions can be answered there. So I know because like these presentations are kind of fast paced, but we just want to make sure that you guys here can understand the content, and the people who are watching the recording can also get an understanding of all the content that we have. And thank you guys always for coming out. I know this is like the first webinar. We have a lot more coming. We have one in a few minutes actually, where the person who sponsored this program, the person who sponsored this big market program, like platform, is actually presenting on cybersecurity. So I would definitely make sure to attend that. And I just want to say thank you for coming out to this first webinar of YSP 2022. And there is, in a few minutes, there's going to be a presentation on cybersecurity. So as always, so feel free to drop right now and head over to that webinar and come with a few minutes early. And so you can drop this webinar right now and head over to the next one, and we'll make sure to meet you there and start a presentation on cybersecurity. Thank you guys for coming out.